Okay, finally for this question 21, then we finish the probability chapters. Now sometimes we need to use NCR and R factorial at the same questions. Actually, it's also happening in the question 20. That means that sometimes you need to have a selection process, but at the same time you also have an ordering process. So it's pretty complicated, honestly. But practice makes perfect, okay? So there are 8 cake shops in the district. So 3 cakes are taken from each cake shop for quality control. So there are 8 cake shops. And then not taken 3 cake shops. Is each cake shops you need to take out 3 cakes for quality control. And quality controller randomly select 3 cakes from the cake selectors. Actually, you have 20 cakes selected. So find the probability that the 3 cakes are all from the same cake shop. So that is pretty simple. For me, at least. So you choose 3 cakes right there, and needs to be from the same shop. But actually, the meaning of the same cake shop has 8 different meanings. So let me denote the S to be the cake shop right there. So that means that you can have the first cake shop same from all from the S1, or all from the S2, or all from the S8, etc., etc. Okay, so that means that actually the meaning of the same cake shop has 8 meanings. But of course, you can see that these 8 meanings has the same mechanism. Is that you need to choose all of them. So that means 3C3. So 3 cakes from the same cake shop. You need to choose all of them in order to make sure they're all from the same cake shop. But in order to tackle this X similar situation, you need to multiply by 8. Of course, you can add the 3C3 by 8 instead of multiply by 8, but it had the same meaning. Okay, so like this. So that is equal to 1 over 253. Okay, for part B. Now there is there may be a misconception right there. Now, of course, you can see same and difference from part A and part B, but here these two are not complementary. Because of the fact that you are taking 3 cakes, you are selecting 3 cakes right there. It's not talking about, like, even for the 2 cakes, you can see that actually this is not complementary. Now let me talking up using S1 as an example. Same, meaning that all of them are S1, right? But you also have the situation, and now let me denote S1, S2, S3 is the difference. But actually, you also have an in-between situation. So that means 2 of them are the same. So this is the in-between cases to making that these 2 are not complementary. So this one is very crucial. Okay, how to calculate the probability that's all from the different cake shops? Okay, how to calculate part B is that you need to analyze the wordings all from different. Now, of course, is to choose randomly choose 3 cake shop, and then randomly choose 3 cake shops, and then for each cake shop you choose 1 cake. Okay, so there is 3C1, 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 and then now in order to choose 3 cake shop, then you need to have another selection process. Is that you choose 8 cake shops, choose 3 cake shops out of 8, and then for each cake shop choose 1 cake. So that is a meaning of this 3C1, 3C1, 3C1. And this 3 is talking about the 3 cake shops. And also that is the numerator, and the denominator is the 24C3 without any restriction. So that is the answer. Now again, you can see that the part A result plus the part B result, the probability is not equal to 1 because they are not complementary. So that is the question 21.